Problem number 5, a manufacturer advertises a particular set of safety goggles have an optical density of at least 1.8. If the incident ultraviolet radiation for a particular process is 230 milliwatts per square centimeter, how much energy in milliwatts per square centimeter will reach the eye if these glasses are worn? The answer is going to be milliwatts per square centimeter. All our units are the same, so we shouldn't have a problem with that. So just bringing back the optical density formula, optical density is equal to the logarithm of the initial beam intensity over the final beam intensity. So what do we know here and what do we not know? What we know is that the initial beam intensity is 230 milliwatts per square centimeter. What we don't know, and that was I0, what we don't know is the I down here. Okay, so let's give this a try. So actually at this stage, this would be a good time for you to pause and see if you can work out the answer to this problem on your own. If you struggle with it, come back here and resume and work through the problem with me. So let's give it a try here then. Okay, so let me write on here. So the optical density is equal to the logarithm of the initial original optical density over the final optical density, which is what we want to know. So the optical density is equal to 1.8 for this particular glass, and it's equal to the log of the initial density, radiation level, which is 230 milliwatts per centimeter squared, and we want to calculate what's the incident radiation that's reaching the eye of the person that's being protected by these glasses. Okay, so the 1.8 is equal to the logarithm of this ratio. So in order to solve this for I, we have to get this out of this logarithm. So what I'm going to do is I'm going to take the anti-log of both sides. What's the anti-log? Well, let's take a look at logarithms. The logarithm of 1,000 is equal to 3. Okay, the idea there is that the logarithm of 1,000, logarithm of a number like 1,000, is the power to which 10 has to be taken to get that number. So 1,000, 10 has to be taken to the third power in order to become 1,000. So logarithm of 10,000 would be equal to 4, because 10 to the fourth is 10,000. Now, any number in between there, like a number between 10,000, 1,000, and 10,000, like 2,500 or 7,500, they're going to be some value between 3 and 4, 3.1, 3.4, and some value between 3 and 4. Because the logarithm of 1,000 is 3, logarithm of 1,000 is 4. So anything between those two numbers is going to have that value. So I can using this, I can now take the anti-log. In other words, this represents, we take the anti-log of this is going to be the number to which we have to take, that we're going to take 10 to in order to get the original number when we do the anti-log. This side is going to be easy. The anti-logarithm of a log is just the number. Millivolts per square centimeter over I is equal to the anti-log of 1.8, which is just 10 to the 1.8 power. Okay, let's clear. So 1.8 to the 10 to the 1.8. There's 1.8, and that's our x. So I'm just going to click on this, and it should give me our answer, which is 63.09. 63, I'm going to call it 63.1 for our purposes. Okay. Let's put that aside there. Oops. 63.1 is the anti-log of 1.8. And if you have any doubt about that, just take 63.1 and find the logarithm of it, and it's 1.8. Okay, so now I'm old school, so I'm going to actually go through this entire process. So I'm going to cross multiply, and 63.1 times I is equal to 230 millivolts per square centimeter, and divide by 63.1. Okay, And that is going to be this is optical density, has no units. So this is unitless. So this is going to wind up being millivolts per square centimeter. And you can see, because one's being 63 being divided into 230, it's lower than the original intensity of the ultraviolet light. So that makes sense, right? So we kind of a second check on this. Not bigger. We know that fraction's the right direction, because if we're wrong direction, it would be more energy reaching is like through the glass, less energy. So for what that's worth, 230 divided by 63.1, oops, 230 divided by 63.1 is equal to 3.65 millivolts per square centimeter. Millivolts per square centimeter. Okay, and hopefully made the range wide enough that if you round it differently than I did, that if you don't round, or if you round more than I did when I did the original calculation, it'll still be in the same range.